The first video on integration, we had seen integration by substitution method. In the second part, we are going to see how to integrate functions based on trigonometric identities and integrals of some special kind of functions. Watch the video till the end to get the complete step-by-step explanation. Now this is a recap of the integration formulae, and in the box I have given the formulas which are actually important. These are the integration formulae for the trigonometric functions, and the basic formulas are used more. See, these two formulas are very important for solving the examples, and it will be giving you a shortcut method to solve the examples. So these are the various integration techniques. In this video, we are going to see integration using trigonometric identities and integrals of some special functions. So now these are the trigonometric formulas which you need to memorize. You need to know all these formulas. Let us straight away start with the examples to get a better idea. First one, integrate the function cos 2x, cos 4x, cos 6x. Now first thing, looking at the example, it should be clear that we can use the trigonometric formula 2 cos cos is equal to cos plus cos. Correct? So over here you can group any two terms first. So now what we are going to do is, you are having cos 2x, cos 4x, cos 6x. Keep cos 2x as it is. Cos 4x into cos 6x. You multiply by 2, so you need to divide by 2 also. So now 2 cos cos is cos plus cos. So cos 4x plus 6x plus cos 4x minus 6x, but cos of minus theta is cos theta, so it is cos 2x. Now what to do is, again simplify the bracket and again use this formula for the two terms. Correct? So again after simplification you will be getting these values. Also remember, we are getting cos 0, 2x minus 2x, but cos 0 is 1. So now your final answer is 1 upon 4 taking outside, sin 12x by x. Now see over here, integral of cos 12x, integral of cos kx, we have seen just previously, is sin kx by k. Correct? So cos 12x integral is sin 12x by 12. Similarly other terms. So the answer is 1 upon 4 into bracket sin 12x by 12 plus sin 8x by 8 plus sin 4x by 4 plus x plus c. Example 2. Integrate the function 1 minus cos x upon 1 plus cos x. Now what we do is, 1 minus cos x and 1 plus cos x is there. So you know the formula for cos 2x. Cos 2x is 1 minus 2 sin square x, or cos 2x is 2 cos square x minus 1. So now cos 2x, instead of that let us simplify cos x. So now since your angle 2x has become x, the angle over here sin square x and cos square x will become sin square x by 2 and cos square x by 2. So now we are just putting the values. 1 minus cos 2x is 2 sin square x by 2, and similarly 1 plus cos 2x is 2 cos square x by 2. Now next we use the integration formula for tan square x. Tan square x over here, it is tan square x by 2. So integral will be sec square x by 2 minus 1, because tan square is sec square minus 1. Why are we doing this? Because we have the direct integral of sec square, which is tan. So integral of sec square x by 2 is tan x by 2 upon, since it is x by 2, you have to divide by half. Minus 1, integral is x. So the answer is, the integral is 2 tan x by 2 minus x plus c. See, each example is done in a different way. Next one is, integrate the function cos raised to 4 2x. Now cos raised to 4 can be written cos square whole square. Now cos square x, by the double angle formula, cos square x is 1 plus cos 2x by 2. So instead of cos square x, we are having cos square 2x. So the angle x will become 2x. Same way angle 2x will become 4x. So we can write it as 1 plus cos 4x by 2 whole square. Simplify the square. open the bracket. So it is 1 plus 2 cos 4x plus cos square 4x. 1 upon 4 taken outside. Now what we do is again cos square 4x is there, that we use the same technique we used just now and write it as 1 plus cos 8x by 2 upon 2. So you will be having first term x by 1, that is integral of 1 is x. So it is x by 4, 1 upon 4 was outside. Integral of cos is sine, but it is cos 4x. So you have to divide by 4. 2 upon 4 into sine 4x. 1 upon 4 was already there outside. Plus it is 1. Integral of 1 is x. But already you have 1 upon 4 and 1 upon 2. So it is x by 8. Plus next term. Again 1 upon 8. Integral of cos is sine. So it is sine 8x. But since it is 8x, you need to divide by 8. So just simplify now all the terms. The final answer what we get is 3 upon 8x plus sine 4x by 8 plus sine 8x by 64 plus c. Next example, integrate the function sine inverse of cos x. Now over here, remember whenever you are having sine inverse type of functions, try to make it as sine inverse into sine, cos inverse into cos, so that the inverse goes out and you will just remain with the angle. So now cos x can be written as sine of pi by 2 minus x. So now what you have is, first term is sine inverse of sine of pi by 2. So you know sine inverse of sine of any theta is theta, that means pi by 2. Minus over here second term is x. So now the integral over here is integral of pi by 2 is pi by 2 constant. So integral of 1 which is x. So pi x by 2 minus integral of x which is x square by 2. So the final answer is integral is equal to pi by 2x minus x square by 2 plus c. Now in the second part of this video, we are going to see integrals of some special type of functions. If your functions are given in these type of forms, directly you have the integrals. Like first one is dx upon x square minus a square, where a is any constant. So like for example, very simple terms, say x square minus 2 square. In that way, the integral is 1 upon 2a log of mod x minus a x plus a plus c. Remember, everywhere log means log with the base e or ln. Similarly, integral of dx upon a square minus x square, dx upon x square plus a square, integral of dx upon root of x square minus a square, integral of dx upon root of a square minus x square, and integral of dx upon root of x square plus a square. You need to memorize all these formulas. See, these are very important forms of the functions which we are going to see examples for each of them. So if your functions are expressed in these forms, then directly you have the integral for them. Now from the set of formula we have just seen, let us prove one of them. Let us prove integral of dx upon a square minus x square is 1 upon 2a log mod a plus x upon a minus x plus c. Now what you do is, the denominator is a square minus x square, which is a plus x into a minus x. Multiply and divide by 2a. So outside it is 1 upon 2a. In the numerator, 2a can be written as a plus x plus a minus x. Okay. So now you just differentiate the, you just take both the terms separately. So it is, first term is a plus x upon a plus x a minus x, which is 1 upon a minus x. Second term is a minus x upon a plus x a minus x, which is 1 upon a plus x. So now individually integrate both the terms. Now you know that 1 upon x type of term integral is log mod x. So first term is integral of dx upon a minus x, which is log of a minus x, and since it is minus x, you have to multiply by minus 1. Second term is 1 upon a plus x. So that integral is log of a plus x. So finally it is 1 upon 2a log of a plus x upon a minus x plus c. This is by the property of log. You know that log of x by y is log x minus log y. Now, next example. These type of examples are really important. You have to integrate the function x plus 3 upon x square minus 2x minus 5. So now basically the integral is of type px plus q upon ax square plus bx plus c. So now px in this type of examples, wherever you are having px plus q upon ax square plus bx plus c type of example, what you need to do is numerator px plus q you want to express in terms of the denominator. So let that be equal to a into derivative of ax square plus bx plus c plus some constant b. Now why you can write in this way? You know that when you take the derivative, the power becomes 1 less. So when you take the derivative of ax square plus bx square, it will be a term in x and constant term. So very simple terms, what you have to do is numerator you express in terms of denominator. So here what is the numerator? X plus 3. That you write it as sum a into derivative of x square minus 2x minus 5, which is the denominator, plus some another constant b. So now simplify. A plus 3 is equal to a into derivative will be 2x minus 2 plus b. So now you are getting the left hand side and right hand side. You just compare the terms having x and the constant term. Just simplifying that, you will be getting a as half, and when you put a as half, you will be getting b as 4. So now our original integral can be written as half into 2x minus 2 plus 4 upon x square minus 2x minus 5. So what we have done is we have put the value of a, which is half, and we have put the value of b, which is 4. Next, let us integrate this function. Now continuing with our function, we have to integrate half into 2x minus 2 plus 4 upon x square minus 2x minus 5. Separate the terms. First term is 2x minus 2 upon x square minus 2x minus 5. Now here our shortcut methods becomes really easy. You could use any other substitution method, but directly use this, it will be very easy. Integral of f dash x upon fx type, it is equal to ln means log with the base e mod fx plus c. So if you consider fx as x square minus 2x minus 5, what is f dash of x? 2x minus 2. So this is of the kind f dash of x upon fx. Its integral is log mod fx. So log mod x square minus 2x minus 5. That was the first term. For the second term, you are having 4. You can take that 4 outside. So it is 4 into integral of 1 minus x square minus 2x minus 5. Now can we write that as x minus 1 whole square minus 6? Remember, we want to just construct in the type of the special forms we have just now seen. We have seen x square minus a square minus x square, and so on. So now x square minus 2x. If 2x is your middle term, what will be your last term? 1. So it is x square minus 2x plus 1 minus 6. Because minus 5 you are writing it as plus 1 minus 6. So now your denominator has become x minus 1 whole square minus 6 means minus root 6 square. It is of the form dx upon x square minus a square. What is the integral of dx upon x square minus a square? 1 upon 2a log mod x minus a upon x plus c. So it is 4 upon 2 root 6, because your a over here is root 6. Ln of x minus 1 minus root 6 upon x minus 1 plus root 6 plus constant of integration c1 plus c2. For the first integral, if we take constant c1, for the second one, say it is some another constant c2. Ultimately, you can write it as some for the last answer, you can write it as some other constant c, where c is nothing but c1 plus c2. So your final answer is integral is half ln of mod of x square minus 2x minus 5 plus 2 upon root 6 ln of x minus 1 minus root 6 upon x minus 1 plus root 6 plus c. Next, integrate the function 1 upon 9x square plus 6x plus 5. Now see, again this is a special type of integral of the form dx upon ax square plus bx plus c. Correct? For this type of examples, whenever you have to integrate function of the type dx upon ax square plus bx plus c, what you need to do is put x plus b upon 2 as t. But let us see actually what we are going to do. 9x square plus 6x plus 5. Now this, can I write it as 9x square plus 6x plus 1 plus 4? So this is nothing but 3x plus 1 whole square plus 4. From the middle term, we have tried to get the last term to make it in the form x square plus a square type of form. So now what we have is 3x plus 1 whole square plus 4. Now till here it is fine. But now you are having 3x plus 1, not directly x. So again use the substitution method and take your 3x plus 1 as some t. Differentiate both the sides, so it is 3 dx is equal to dt. So now instead of dx, what will you write? Dt upon 3. So it is 1 upon 3 dt, and what will become the function? Your function will become 1 upon 3x plus 1 whole square plus 4. Instead of that, 1 upon t square plus 4. So now use our standard integrals list of formula which we have seen. Integral of dx upon x square plus a square is 1 upon a tan inverse x by a. So it is 1 upon 6 tan inverse of t by 2. Okay. So ultimately your answer is, integral is 1 upon 6 tan inverse of 3x plus 1 by 2 plus c. Next example, integrate the function 1 upon root of 7 minus 6x minus x square. Now this is of the type integral of dx upon root of ax square plus bx plus c. So now what do we do for this type of sums? Again over here, your ax square plus bx plus c, try to make it in some whole square. So first of all, the coefficient of x square, we generally take it as positive. So we can write this as 16 minus x square plus 6x plus 9, which is 4 square minus x plus 3 whole square. Correct? As I told you, from the middle term, try to get the last term. Middle term is 6x. Okay. So your last term should be 9. So since your last term is 9, accordingly you have to plus and minus the other constant. So now in short, this can be written as 4 square minus x plus 3 whole square. The 7 minus 6x minus x square can be written as 4 square minus x plus 3 whole square. Now again, like in other examples you do, just substitute x plus 3 is equal to t. So you have dx is equal to dt. So your integral has become integral of 1 upon 4 square minus t square dt. Now 1 upon root of 4 square minus t square. So what is the standard integral? Integral of dx upon root of a square minus x square is sine inverse x by a. So this is sine inverse of, instead of x, what you have t. What is t? X plus 3 upon a. What was your a? 4. So it is sine inverse of x plus 3 upon 4 plus c. So we are using two things over here. First thing is the rule how to solve integrals of the type dx upon root of ax square plus bx plus c. And second thing is a special integral dx upon root of a square minus x square. Next example is you have to integrate a function of the type px plus q upon root of ax square plus bx plus c type. So integrate x plus 2 upon root of x square plus 2x plus 3. Here the technique is again over here, the denominator has to be written as some form of numerator. So px plus q, you have to write it as a into derivative of ax square plus bx plus c plus some another constant b. Again I am repeating over here, since the derivative of the function of kind x square will give you x type of term. So px plus q, we are writing it as a into derivative of ax square plus bx plus c plus some constant. Now over here x plus 2 has to be written as a into derivative of x square plus 2x plus 3, which is 2x plus 2 plus some another constant b. Again the technique is same. What you need to do is compare the terms having x and the constant term. So simplifying, you will be getting a as half and b as 1. So now our original integral is written as half of 2x plus 2 plus 1 upon root of x square plus 2x plus 3. Again, separate both the terms. The first term is 2x plus 2 upon root of x square plus 2x plus 3. And the second integral is 1 upon root of x square plus 2x plus 3. Now, individually we will find the integral for both these functions and then combine it. See, these type of examples look difficult, but if you solve it step by step using all the formulas, you can get the answer easily. Our original integral has been divided into two parts. Let us get the answer for the first one. First integral is half of integral of 2x plus 2 upon root of x square plus 2x plus 3. Now again I am telling you this can be solved using two methods. One is our very direct method. Integral of fx raised to n into f dash of x is 1 upon n plus 1 fx raised to n plus 1. Again I am telling you this is a shortcut method. It makes it very easy. In this case just consider fx as x square plus 2x plus 3. And your fx is raised to minus half because it is 1 upon root. So it is fx raised to minus half. Your n is minus half into f dash of x. Your n is minus half, so it is 1 upon minus half plus 1 is 1 upon half. And fx raised to again minus half plus 1 means half. So fx raised to half means root of fx. So your integral is directly half upon half, which is 1, because outside already 1 half was there. So it is half upon half, which is 1 into fx raised to half, means it is root of x square plus 2x plus 3 plus constant. This is a one way of doing it. Another way is just substitute x square plus 2x plus 3 as t. Actually both are similar ways, but here directly if you use the formula in one step you get the answer. So if you consider x square plus 2x plus 3 is equal to t, 2x plus, take the derivative, so both the sides, so 2x plus 2 into dx is dt. So here your integral is, half was already there outside, integral of dt upon t raised to half, that is t raised to minus half. T raised to minus half, integral is t raised to minus half plus 1 upon minus half plus 1. So it is half upon half t raised to half plus c, which is root of x square plus 2x plus 3. This is the integral of the first part. Now let us solve the second part. The second integral is integral of 1 upon root of x square plus 2x plus 3. Again this is of the type x square plus a square, dx upon root of x square plus a square. So again I am telling you, using the middle term try to get the last term. So x square plus 2x, what should be the last term? 1. So now since I am having 3, you have to write it as plus 1 plus 2. So now it is 1 upon root of x plus 1 whole square plus root 2 whole square. 2 is root 2 whole square. So it is of the kind dx upon root of x square plus a square. So the integral is log mod of x. Instead of x you have x plus 1 plus root of x square plus a square, means our original function, x square plus 2x plus 3. Now combine both the integrals. So your final answer is I is equal to root of x square plus 2x plus 3 plus log of mod of x plus 1 plus root of x square plus 2x plus 3 plus constant c. Another example, integrate the function 6x plus 7 upon root of x minus 5, x minus 4. So again this is of the type px plus q upon root of ax square plus bx plus c. But instead of directly ax square plus bx plus c, you are given x minus 5 into x minus 4. Just open the bracket, it is x square minus 9x plus 20. So now our original technique, write px plus q as sum a into derivative of ax square plus bx plus c plus some another constant b. So 6x plus 7 is equal to a into derivative of x square minus 9x plus 20, which is 2x minus 9 plus some constant b. Now simplify both the terms. What you do is first you gather the term having x and then you take the constant term. Equate the coefficients of x and the constant term. Solving it, what you get is b is 34 and a is 3. So now just put your values of a and b. So your integral is 3 into 2x minus 9 plus 34 upon root of x square minus 9x plus 20. So now this, taking 3 outside, you can write it as 2x minus 9, just separate both the terms. First term is 2x minus 9 upon root of x square minus 9x plus 20, and second integral is 34 upon root of x square minus 9x plus 20. Let us individually solve both these integrals. So now for the first integral, it is 3 into integral of 2x minus 9 upon root of x square minus 9x plus 20. So just now we had seen previously, you can either use substitution method or you can use fx raised to n into f dash of x. This here your fx is x square minus 9x plus 20 and it is again raised to minus half. So it is 3 upon half, which is 3 into 2 into fx raised to half, means it is 6 into root of x square minus 9x plus 20 plus constant c. Now our second integral is 34 into integral of 1 upon root of x square minus 9x plus 20. If your middle term is 9x, the last term should be 81 by 4. But it is 20. So 20 is 81 by 4 minus 1 by 4. So now it is in our standard form dx upon root of x square minus a square. So your integral, second integral is 34 log of x minus 9 by 2 plus root of x square minus 9x plus 20. So the final answer is integral is 6 into root of x square minus 9x plus 20 plus 34 into log of mod of x minus 9 by 2 plus root of x square minus 9x plus 20 plus c. See, integration is a very vast topic and so we have divided it into parts. I hope this part is understood. Please like and share the video and subscribe to the channel for the remaining parts on integration.